let me change my view to graph paper here. Okay. What we're going to talk about today is we're going to talk about solving two equations and seeing what the solution of the two equations are. Now, the problem is that the two equations also have two variables. So it's not like, you know, it's a real simple little equation here or there and you've got to solve it. Now, the whole chapter is going to be on systems of linear equations, okay? We will use today graphing. We will use, tomorrow we'll talk about substitution. And then next week we'll talk about a couple other ways that you can solve to find out solutions to these two different equations. What we're looking at right now will only be two different equations, okay? You won't have 3 or 4 or anything like that. So what you're going to come up with is the solution is going to be an ordered pair, okay? The solution of systems of linear equations is an ordered pair. So the whole point of this is we're going to find a point where the solution is. Now, what it's going to look like is this. You're going to have a coordinate plane here, okay, and you're going to have two lines. Let's say we got a line going here and a line going there, okay? The solution to those two linear equations, okay, those are two linear equations. The solution is this point right here where they intersect each other, okay? That point, whatever the coordinates of that point is the solution to this linear system, okay? Now, obviously that point right there is a little hard to come up with because it doesn't fall on one of the graph lines. It doesn't fall where two graph lines intersect. There will eventually be those times that will happen, okay? You really don't have it today. It's going to be, you know, you might have something like 1.5 where it falls halfway in between the line, but it's not going to be like right in the middle right there. And you're going to have to go, oh, okay, that's, you know, it falls between 1, 2, so it's like 2.5, and then it falls in between 1, 2, so that, you know, that point would be like 2.5 and 2.5, okay? You're not going to really have to do some of that today, okay? Eventually you will, okay? And eventually we'll get into graphing calculators. You'll get, we won't this year, but you know, in coming years you will have graphing calculators that will do a lot of this for you. Right now you need to understand how to do it, so we're going to do it. Now, the first step in solving linear systems is step 1 is to put the equation in a form that is easy to graph. Okay? So, probably the easiest form to put it in is slope-intercept form. Okay, that's, you know, if you think of one that's easier for you, you can do that. Okay, but for the most part, if we put it in slope-intercept form, okay, that's probably the easiest way to do it. Okay, now, let's talk about the next step. The next step is to graph both equations. That's going to be step 2. Now, obviously, we're graphing them on the coordinate plane. I mean, obviously, you don't graph the equations other ways. Okay? The third step is to estimate the point of intersection. Okay? Just like we did up here, we estimated that our point of intersection was right there. Now, when it says to estimate, that's where you're going to have to look at it and go, okay, what are the coordinates? Most of the time, like I said, your coordinates are going to be whole numbers. Sometimes they won't be. Not very many of them, okay? Most of them, like I said, will be whole numbers, on those graph lines that you've done. Now, you can understand why you really need graph paper. Okay? If you just do this old-fashioned way, like, you're just putting your little tick marks and, the spacing's different, then you could end up with something that is totally wrong. Okay? So you really got to have graph paper. I guess it could be done, but you're going to have to be probably more lucky than you are good, to get it done that way. Now, the fourth and final step is to check the coordinates of our point of intersection into the original two equations. Okay, now it seems like an awful lot. I'm not going to lie to you. It's not like just, that's easy. I mean, it's easy to a point, but you can understand why all of this stuff that we've been doing is starting to build onto each other. Okay, so let's look at an example. We're going to look at number 20. Number 20 says this: y is equal to negative x plus 3, and y is equal to x plus 1. Okay, y is equal to negative x plus 3, and y is equal to x plus 1. All right. Now, first step is to put it in a form you understand, or an easy form for you to be able to graph. Well, it's already in there. It's already in. This is slope-intercept form. So the first step's already done. Now, most of the ones you're going to do are not going to be that way. Okay, they're going to be not in slope-intercept form. Okay, so you're going to have to remember quite a few different things that we've talked about in Chapter 5 and Chapter 6. Actually, more Chapter 5, because Chapter 6 was dealing more with just inequalities than it was anything else. So, I need to graph those two equations. So I'm going to get over here and get my little graph. Whoa, wow, I didn't do that, and it just popped up. Yeah, we'll use it. Okay, so there's our graph. Now, in our graph, we have the first line is, this one here is negative 1 slope and y-intercept of 3. So remember, negative 1 slope means the line is going like this. All right, so 3 would be, well, and I'm going to have to, hang on here, bear with me a second. I'm going to have to delete this. Well, I can't get it deleted. There we go. Because it wasn't drawn on the line there. It was in halfway in between lines. Okay, why aren't you doing it? Okay. Now, so what we have is we have negative slope and 3 is our intercept. So 3 is our intercept, 1, 2, 3. So we're going to start there, okay, and we're going to go over 1, down 1. So it's basically just going to do this. Okay, this one's a fairly easy one because it's just 1's your slope. And when 1's your slope, you're just going to the next box, basically. Okay, so that's our first one. Okay, that's your first equation. Second equation is x. So our slope for our second equation is 1 is the slope, and the y-intercept is 1. Okay, so it's going to be right here. There's 1. So I'm going to go, our slope of 1 would be like this. So when you're using graph paper, you can already see what our point of intersection is. So if I draw the lines there, and then this one here, okay, there's your point of intersection right here. Okay, so we're saying then that our point of intersection is 1 and 2, right? So 1 and 2. So that's what we're saying our point of intersection is, 1 and 2. Okay, so this is step 3, right, I believe? Yep. That's step 3. So step 4 is to take that point of intersection and plug it in to our 2 original equations and see if it checks. Okay, remember, this is x and that's the y. So we plug it into this first one, that gives us 2 is equal to negative 1 plus 3. Well, 2 would be equal to 2. So it checks in that one. Plug it into the other one, you get 2 is equal to 1 plus 1. So 2 is equal to 2. So it does check out. So our solution then is 1, 2. That's your solution. All right, now, let's look at one that's a little bit harder. They always got to be harder, don't they? Can't ever be easy. All right, let's look at number 26. Number 26 says 3x plus 6y equals 15. And then the other one is negative 2x plus 3y equal negative 3. Good thing is we're not dealing with inequalities, at least. Because eventually you have to do it with inequalities as well. So, and you get the shaded area, non-shaded area, all that stuff. So, all right, so this one here, I'm going to put in slope-intercept form. So step 1 is I got to move the 3x over there. So it gives me 6y is equal to negative 3x plus 15. Huh? What? No. All right, next step is to divide by 6 to everything in our problem. So that gives me y is equal to negative 1/2 x plus 15 over 6 reduces to what? Do what? 5 over 2, which is 2.5, right? Okay. So 5 over 2. So there's our first one. Then we got to solve the second one. You will notice on all of these, okay, you'll notice here in a second, let me do this one. Take that over there, it becomes a positive 2x, so you have 3y is equal to 2x plus negative 3. Divide by 3, divide by 3, divide by 3. That gives me y is equal to 2/3 x minus plus a negative 1. Now, you will notice in these problems that you're going to have this. You're going to have one slope that is negative and one slope that is positive. Okay, because they can't intersect each other if the slopes are not opposite of each other, positives and negatives. Okay? All right, now, well, I think that's, let me look here, that looks about right, yeah. Now, all right, now I got to graph them. Okay, so I've got to graph these little jewels. Okay, so my first one is 5.5. So that's 2.5. So 2.5, there's 1, 2, 2.5 is right there. And I'm going to go ahead and put the dot of my other one, which is negative 1. Negative 1 is right here. So we know that, I'll erase this in a second here. We know that this one goes up like that. We know that this one goes down like that. Okay? So obviously our point of intersection is going to be there in there. So I'm going to go ahead and take and let's do the black one here. Let's go 1/2. So what is 1/2? That's rise is 1, correct? Okay. So I'm going to go down 1, which would be right there, and I'm going to go over 2, which would be 1, 2. Okay, everybody understand that? I went down 1, which means I go from 2.5 to 1.5. Okay, and I go over 2. Then I'm going to go down 1, which is here, and go over 2, which is there. Okay, so there's your first one. Now I'm going to do the other one. The other one is 2/3, so that means I'm going up 2 over 3. So I go up 2, 1, 2, and over 3. 1, 2, 3. I go up 2, 1, 2, and over 3. 1, 2, 3. So there's that one. Okay. Then the other one is in black. Let me do it in black here. Try to. Okay. So our point of intersection is right here, and that's going to be what coordinates? Brandon. No, opposite. 3, 1. 3, 1. So 3, 1 is our point of intersection. Okay, now I got to plug those in to the original equation. So I go up here to the original equation, and that gives me 3 times 3 plus 6 times 1 equals 15. Well, that's 9 plus 6 is equal to 15. 15 is equal to 15. Okay, then I plug it into the other one. That gives me negative 2 times 3 plus 3 times 1 equals negative 3. Well, that would be negative 6 plus 3 equal negative 3. That is negative 3 equal negative 3. So my solution is 3, 1. Okay? All right. All right. So, your homework. I'm going to give you some time in class so you can start working on it. What? Nope. 18 through 34 even, and 35 through 36, or 35 and 36. Originally, it was going to just go 18 through 36, so feel fortunate that I cut them in half, basically. Yeah. So you got quite a bit, like I said, you got time left in class. Let's go ahead and get that working and going.